Hi friends, let's have a look at problem 3279, maximum total area occupied by pistons. This problem is marked hard by lead code. So actually if you can grasp the main points, so this problem actually can be easier. So in this video, we're going to explain a solution. Basically, we are going to track the transition time sequence and count the directions as the direction changes. So overall, the time complexity is given by this line. So here n is the length of the directions or positions. These two have the same length. And k is the length of the transition time sequence, which is to be specified during the coding part. So first, let me quickly read through the problem statement so that we can digest the main point. So here we have several pistons, and we want to calculate the maximum possible area at the pistons. So here we are given an integer height representing the maximum height a piston can reach. Secondly, so an integer array called positions, where positions I is the current position of piston I, which is also the area at it, right? In other words, the height of this piston. And also we are given a string called directions, where the S element is the current moving direction of piston I. So it's either U for up and D for down. So every second or every unit time, so every piston moves in its current direction by unit. In other words, if it's up, then it's going to be increased by 1. If it's down, it's going to be decreased by 1. So the second one is also very important. If a piston has reached one of the end, so this is the bottom, right? The second one is high, is the top. Then its direction will change. So we want to return the maximum possible area at the pistons. So basically, we want to find the sum of the positions, but these positions are changing, right? So according to the directions. So here we have two examples. You can do it manually. So here, because this is the up and down, so if next second you are going to have 3 and 4, right? So anyway, so this sum is 7 for this problem. For this one, so here is an example. After 3 seconds, so you get 3, 3, 3, and 6. So the total is 15. Basically, if we want to do it manually, just by analyzing such a simple example, it will be very easy to digest for us. But the problem here is that the scale. So here the height can be as long as 10 to the power 6, right? So in other words, you cannot do simulation second by second, right? The second one is a consistency assumption. So the directions and the positions, this is a sequence length up to 10 to the power 5, and the height can be 10 to the power 6. But if you do it second by second, you will have 10 to the power 6 options. That's not good, right? Especially if you multiply by the length. So also the position is in between 0 and the height. This is for consistency. Here the direction is either up or down, right? So with that said, basically we could interpret that for this problem, time complexity is very important because we cannot simulate the process by consider all the different seconds, right? Because the height is can be 10 to the power 6, but if you from bottom to go to the very top, and then from the top to down, then it's 2 times the height. But if the height is this number, then you will have 2 times 10 to the power 6. And then you times the length, for example, if it's the maximum length, then you will out sort of 10 to the power 11. For sure, it will not pass the test cases. So here, basically, we are going to track the transition sequence and time sequence and the directions. So here, actually, this then works through for this problem. So I would suggest you can do it. So here I use the example 2 to do this demonstration. So basically, from first second, second up to third second, then this guy will reach to the top, then it's change direction, right? And then we can so this is the details for this problem. But if I walk through you here with this steps, you maybe got lost. But the choice for this problem is that we can first do the coding, and then in between you can try to digest the logic in the coding, and then you can come back and then walk through this example. So with that said, let's look at the coding part. First, I'm going to count the directions, because if the direction is up, next second it will contribute to the area positively, and if it's down, it's contributed to the total area negatively, right? So first let's count this one. So this can be done by this collections counter, right? So I changed this direction to be theirs. It's just for the ease of writing. So that's one part. Another part is that I want to monitor when a piston arrives at the top and the bottom and their time, right? So let's do top arrival times. So it's going to be a collections default dictionary, right? So let's call the container int. So in other words, the default value will be 0. So similarly, we will also need to track the pistons which arrives at the bottom, because next second it's going to change direction. So bottom arrival times. So it's also a we make it a dictionary, right? So with that done, let me do some mark. So this first get the direction use and these count, right? The next two lines is monitor the piston, the number of pistons arriving at top or bottom. So with this, we can get the key will be the arrival time, and the value is the number of pistons, right? So k will be arrival time, and the value will be a number of pistons arrive either top or bottom at that time. So now let's fill up these two dictionaries. So for this, let's for y and direction in zip positions and theirs. Notice that these two lists have the same length, right? So first let's check if direction is up, right? Then we have the y. In order to arrive at the top, so it's going to take the height minus this coordinate. So in other words, top arrival times. So it's arrive at this time. So we are going to increment this by 1, right? And then if it arrives at the top, then after each of the same number of height minutes, seconds, it's going to arrive at the bottom. So we have bottom arrival times. So this will be going to be h minus y plus h, right? So let me write it as 2 times h minus y. So this will also increment the by 1. Otherwise, the direction will be down, right? So if you go downwards, then it will take you this y time to arrive at the bottom. So you get this one. And then if you take another h second, it's going to arrive at the top. So we also have top arrival times. So it's going to be h plus y. Also increment this by 1, right? So here let's print out this one to give it an idea. So let's print top arrival times, and also let me also print out bottom arrival times. So here we are using which example? This first example, right? So because this 2 is up, right? Then after 3 seconds, it will first attain the top. So there's a 1 count, and then after another 5 seconds, it will go to arrive at the bottom. So you have this one at time 8, right? So for the 5, right? So direction is down. So after 5 seconds, so it's going to arrive at the bottom. So you have 5, 1. Then once it arrives at the bottom, then after 10 seconds, another 5 seconds, it's going to arrive at the top. So we have 10, 1. So overall, the arriving times will be 3, 5, 8, 10. And these times, at this time, any of these 10 points, so there will be pistons arriving either at the top and the bottom. In other words, some will change directions, right? So with that said, let's continue our coding. So now what we are going to do, we want to find the transition times, right? So for this, because we want to find all the keys of these two dictionaries. So let me first get this transition times. So we are going to use set. So top arrival times. So we are going to get its keys, right? And then we're going to union. So let's see. So we're going to use bottom arrival times. As we start from 0, we also want to include 0. So you will see if we union with 0, it will bring us some convenience, right? So we also want to sort this guy. So let me call it transition time sequence, right? So it's sorted transition times, right? So if you like, you can print out this so that you can have an idea. So let me copy this one. For this example, the transition time sequence will be 0, 3, 5, 8, 10. Let's run it. You have 0, 3, 5, 8, 10, right? So now we are ready to prepare the return. So now we want to continuously track the change of total areas at the pistons. So we're going to using a running variable. So let's call it say current, right? So what I want to do is initialize a result, and also the current is going to be the sum of positions, right? So this is the area at time 0, right? Initial position corresponding to the first element in this transition times sequence. So next, we are going to, from time 0 to the next transition time, there will be some changes in area, right? So we want to monitor that. So here, let me do this. For T1, T2 in, so let's use iter-tools, say pairwise. I don't know why it does not directly come out. So we are going to have this one, right? So actually, so for example, in this example, this iter-tools pairwise transition sequence will be some tuple like this, 0, 3, and 3, 5, and 5, 8, and 8, 10, right? So this just give you an example. So now what we want to do, so this is a time change, right? Delta is T2 minus T1. So from here, you can also understand why we add a 0 here, right? So in this time, right, so we check the current direction status. So let's say there are k up directions. Then each time you move up, the area will be increased. And then if you go down, there will be decreased, right? Then the current actually, how does it change? The change, then there's count, right? So we want to find the up directions, right? So this is the area increment. Then also we want to find the decrement times delta, right? So this is the area in this area change in this part. Then what we want to do is we do result equals result max and current, right? And then once we arrive at T2, and then so according to the arrival times, top arrival times and bottom arrival times, then we want to change the count. We want to recount how many directions are up and how many directions are down. So at this time T2, there are some. So we track this one, top arrival times T2. So these are the number of pistons arriving at the top. So then it's going to change its direction to be down, right? So basically, there's count up is decremented by this number, and there's count down is incremented by the same number, right? So this is the one. And also we consider the bottom, right? So the bottom arrival times at T2. So at this time, this number of pistons arrives at the bottom. Then it's going to change direction. Then the third count up is going to increment by this number, and the same idea. So the down is going to be decremented by this number, right? You can see here this part and this part basically says that the number of ups and number of downs total is the same, right? Because it equals to the length of the directions. That's balanced, right? Once you have some change direction, then for example from up to down, then up will decrement and down will be incremented. So that's it, right? So at each transition time, we can do this comparison. Then the final result will be the result. Let's return the result. So this will be our full code for this problem. Let me do a quick test. Yeah, it passes the first example. Now let's look at the second example. Yeah, it's okay. Now let's submit. Yeah, it passes all the cases. So as I said, so yeah, doing this code, and then after we do this code, let's go back to here. Let's walk through. And first, the time complexity. So basically, ON is the loops here, right? And the k time logarithm k is here, the sort, right? And all the other parts are just O of n. So then you can see and t equal for the second example, or first I use the second example. So here we have 3 ups and 1 down. Then the top arrival time, so 6. This 2 will arrive at the bottom top and time 6, and this 2 also will be arrive at the bottom at time 2. And here 6 is down, then takes 6 minutes to down, and then takes 12 minutes to up, right? So this 3 actually takes 3 seconds, not minutes, 3 seconds to the top. So here we have 1. Then 3 plus 9, the height, is 9, so it takes 9 to the bottom, right? Then we get 0, 3, 6, 9, 12, the transition time sequence. Then when we arrive at times 3 and just before that, then the result, current result is 9, right? Before, right? Then there will be one piston, right? At times 3, change direction, right? So it will arrive at top. So the time is this, and then we are going to the increment of the area, because it's time times 3, right? 3 up, because we have 3 ups. The 3 ups both move this number of time. So this increment. Also, we have one going down, is then decrement by 3. So overall, this is 15. So we get 15. Actually, 15 is the largest area for this problem. But once you arrive here, then you are going to update the direction counts, because there's one going to the top, it's going to move down, right? So down is incremented by 1, and up is decremented by 1. Overall, the sum is 4. So in the same spirit, you can check time 6 and time 9 and time 12, right? So this way, you only need to check at the areas at the transition time, and then you get the final result. So I guess with that said, that's basically about it for the current problem.